This is an example of a compound inequality using the word and. When the word and is used, this is an intersection, and it contains only the elements that belong to both sets. When graphed on a number line, this will include the numbers where the two lines overlap. So let's first solve our inequality. And with the one on the left, I prefer x on the left side, so I'm going to reverse the order. When reversing the order of an inequality, remember to change the direction of the inequality sign because you're reversing what's being said. If negative 10 is less than or equal to 3x plus 2, then 3x plus 2 will have to be greater than or equal to negative 10. So now let's finish solving. First, we subtract 2 from both sides to isolate the term containing x. Next, divide both sides by 3. Here we have our solution. X is greater than or equal to negative 4. Now let's solve our inequality on the right. First, subtract 2 from both sides to isolate the term containing x. Now we'll divide both sides by 3. And here we have our solution, x is less than 5. This is a compound inequality, so our final solution is x is greater than or equal to negative 4 and x is less than 5. So now we're ready to graph this. Here we have our number line. Let's graph our first inequality in green. This inequality has an equal sign under it, and this means that negative 4 is included. So on the graph we use a bracket, which means it includes negative 4, and the numbers that are greater than negative 4 go toward the positive end of the number line. So now let's graph our second inequality, and let's do it in purple. This inequality doesn't have an equal, so it will use a parentheses because positive 5 is not included, and the numbers that are less than 5 point to the negative end of the number line. So because we're doing a compound inequality using the word and, where are the numbers that are our intersection? Looking at our graph, we see that the place where the two lines overlap each other are from negative 4, including negative 4, up to 5, but not including 5. So all of the numbers in between these two red lines will be the numbers that are our solution. These are the numbers that are both greater than or equal to negative 4, and at the same time, they're also less than 5. So now let's draw the graph of our solution. This is the final graph of this compound inequality. On the left, we have our solution written in set builder notation. When the variable is in the middle between the two inequality signs, this shows that x is a range of numbers. Because the inequality closest to negative 4 has an equal, negative 4 is included, but 5 is not included. Here on the right, we have our set written in interval notation. The bracket means it includes negative 4, and then it ends at 5 and does not include 5. So this shows the range of numbers that's both greater than equal to negative 4 and less than 5.